Can somebody tell me what is the line joining the two matrices AB? Well, quote unquote line, right? What is that? What is that? Set of all? What do you mean by set of all matrices between A and B? What do you mean by in between? That's not guaranteed, right? All the time. No, what did we do? You just have to mimic this, right? What did we do here? We took 2 points in C. C could be anything, right? It could be Sn plus plus or it could be something else. I took 2 points. In my case, in the current situation, I have taken two matrices. And what is the line? It's lambda x plus 1 minus lambda y, right? What should I do here? Same thing. Lambda A plus 1 minus lambda B. Obviously, this is symmetric, right? So lambda is between 0 1, okay? So this is symmetric. Okay. Of course, I'll write lambda between 0 and 1. This is clear, right? What else I have to show? It's obviously n cross n. I have to show that this is positive definite, right? In this case, how do you prove that? You take x transpose lambda. So you take this matrix. I have to show that this is greater than 0 for every x, right? This is the definition of positive definiteness. Greater than 0, not greater than or equal to. So how do you show this? Huh? So this implies what? I can write this as x transpose. I'll pull lambda out, ax plus 1 minus lambda times x transpose bx, right? Well, x transpose ax is always greater than 0, right? Because a is positive definite. X transpose bx is always greater than 0 for every x because b is positive definite. So I'm taking what is called convex combination, right? Lambda times something positive plus 1 minus lambda something positive is strictly greater than 0. Do you agree? So it is convex. Well, interestingly, it's more than convex. Let's see other geometries. That's why geometry helps, right? So, do you know what a cone is? What is a cone? How do you define cone? Okay, let's look at ice cream cone, right? So this is your ice cream cone. How do you define? Well, all the points here, right? So that's an ice cream cone. Well, you take an infinite ice cream cone, not truncated, right? So how do you define this cone? Think. Geometry, right? High school. So how do you define this? What are the characteristics of this cone? Huh? How do you define this cone? Huh? Yes. How do you define this cone? You take a point, right? Well, let me start at origin. Okay, so this is origin. If you take a point, that's a vector, right? Now, I can scale it by any number, right? For example, I scale it by huge number, it goes here. That vector is also there in the set. Do you agree? Huh? Do you agree with that? So no matter what point you pick this point, yeah, you take this, you scale it by any non-negative number. Of course, you can scale it down also. Let's say you multiply by half, it will come down, but still it's there in the set, right? That's how you define a cone, right? So let's define that. So definition: a set C, of course, a subset of Rn is a cone if you take any for every x in C. What should I do? I should multiply it by a number. Okay, so alpha x also belongs to C for every alpha greater than or equal to 0, right? You scale it down or up, but you should not reverse the direction, right? You cannot multiply it by minus something. Okay, that gives you a double sided cone, right? So that's how you define double sided.